Hi everyone, I'm Wanyu. I'm a PhD student at the University of Virginia. Today I'm going to present our work on iterative text revision, done with my excellent collaborators and mentors at Grammarly last summer. In this talk, I will first describe the task of iterative text revision, then describe our framework for addressing this challenging task, present our findings on human versus model revision behaviors, followed by conclusions. Now let's get started with the introduction. There has been extensive research done on the theory of writing, dating as far back to the 80s. It describes writing as a complex and effortful cognitive task, where writers balance and orchestrate three distinct cognitive processes: planning, translation, and revision. However, contrary to the theory, in practice, as we write, we may jump ahead to a later stage of the writing process and then jump back. In other words, our writing process is not a linear but recursive process. In this work, we focus on the revision part of the writing process. According to the previous studies, human writers are unable to simultaneously comprehend multiple demands and constraints when producing well-written texts. Therefore, they turn towards making successive iterations of revisions to reduce the number of considerations at each time and improve the overall quality of their writings. Previous works on iterative text revision have three major limitations. First, they simplify the task to a non-iterative original to final text paraphrasing task. Second, they focus largely on sentence-level edits. Third, they focus on edits within individual domains. And all of those three factors are limiting our understanding of how text revision happens in the real world. In this work, we propose a novel iterative text revision dataset. Compared with previous works, our dataset is larger in scale, works on different revision iterations, and multiple revision granularities. In addition, we propose a new edit intention taxonomy that can categorize different types of edits across multiple domains, and we release all these edit intention annotations as a basis for developing future corpus and computationally modeling the task. More specifically, we select three domains: Wikipedia articles, academic papers, news articles, to cover different human writing goals, formats, revision patterns, and quality standards. The three domains consist of formally written text, typically edited by multiple authors. To better understand and model the real-world iterative text revision task, we propose the IteraTeR Framework. First, we created a novel generalizable edit intention taxonomy. Using this taxonomy, we collect complex text revision annotations with crowdsourcing across three domains. Using this dataset, we computationally model the iterative text revision process using state-of-the-art text editing and generation techniques and provide insights into the challenges of this task. Now I will get started with our edit intention taxonomy. At the highest level, we categorize the edit intentions into ones that change the meaning or information contained in the text, which are the meaning changed edits, and ones that preserve those characteristics. Since our goal is to understand edit intentions to improve the quality of writing, we focus on categorizing edits in the later category, and we further divide it into four subcategories. The first category is fluency, which fixes grammatical errors in the text. The second category is clarity, which makes the text more concise, readable, and understandable. The third category is coherence, which makes the text more cohesive, logically linked, and consistent as a whole. The final one is style, which conveys the writer's writing preferences, including emotions, tone, voice, etc. In general, our edit intention taxonomy is applicable to multiple domains, multiple edit granularities, and multiple revision depths. Based on our proposed taxonomy and collected dataset, we first manually annotate 4,000 edits across 3 domains, which achieves moderate inter-annotator agreement. Then we build a edit intention prediction model to automatically label the remaining dataset to construct the automatic annotated dataset, which is what we finally train our iterative text revision models on. To summarize, our iterated dataset has over 31,000 document revisions with more than 196,000 edits, which have a relatively balanced distribution over 3 different domains in terms of the document revisions. After getting the fine-grained annotations for each edit, we start to computationally model the iterative text revision process. So here is how the system works. Given a draft document with n sentences, we first predict the type of edits needed for each sentence. Then we pass the edit intention as well as the source sentences into a text revision model to get a revised document. Then we feed both original and revised document to a stop revision evaluator to judge whether the document needs another round of revision. You may refer to our paper for more details on the edit intention classifier and stop revision evaluator. We repeat the process iteratively and feed the source and revised document pairs each time to the stop revision evaluator to see if further revisions are still needed. This process stops until the evaluator finds that there are no more revisions to be made, or our system is reaching a predefined maximum revision depth. In this work, we have tried different text revision models. Specifically, we experiment with both edit-based models Felix, which performs tag and insert operations, and generative models BERT and Pegasus, which are large pre-trained transformer-based language models. Further, we use different training configurations to evaluate whether edit intention annotations can help better modeling the text revision task. We see that all models perform better with the edit intention annotations, and across all models, Pegasus with edit intentions achieves the best performance. So we adopt this model for our following experiments. To better understand the gap between our text revision model and actual human revision, we further compare and analyze human and model revision behaviors. More specifically, we compare the quality of documents revised by human and models and test the model's ability to stop revision in the iterative process. By analyzing the edits made by the state-of-the-art text revision model and comparing them against human revision patterns, we take a significant step in understanding and exposing the challenges of computationally modeling iterative text revision. First, we ask a group of proficient linguists to make pairwise comparison on model revised documents and ground truth human revised documents. In terms of the overall document quality, there exists a big gap between the best performing text revision model and human revisions, indicating the challenging nature of this modeling problem. We further conduct fine-grained quality evaluation of the revised documents in terms of readability, fluency, coherence, and content preservation. While model revisions can achieve comparable performance with human on fluency, coherence, and content preservation, human revisions still outperform model revisions in terms of readability. This observation motivates future research on building better text revision models for this task. We also test the model's ability to learn to stop revision in the iterative process by feeding the model its own output from the previous iteration and letting the model make revisions until it stops. We count the total number of iterations for a given document that model has made revisions on. we find that Felix cannot decide whether or not to make further revisions. As a result, it always keeps revising and until it reaches the maximal revision depths. Pegasus model is able to pick up the nuance of iterative revision and learns to stop revision after a certain level of quality has been reached. However, generally, Pegasus prefers to make more iterations of revisions than humans. These findings suggest that current text revision models cannot perform as efficiently as human does in the iterative text revision process. In conclusion, in this work, we develop a novel added intention taxonomy that is more generalizable to multiple domains, granularities, and revision depths, and we construct the iterator dataset to develop future works on the iterative text revision task. We also propose an iterative text revision modeling framework and analyze the gap between model and human revisions. If you are interested in our work, you can easily import the data and model checkpoints with a few commands from Hugging Face. We also have a follow-up work which presents our iterative text revision system in details, and is going to be presented in the first workshop on intelligent and interactive writing assistants at ACL this year. In this paper, we released a larger version of the iterator dataset and further improve the iterative text revision system. Thank you for your interest in our work, and we look forward to having more discussion with you.